Good day and welcome to this episode of Engineering Mathematics. And we're going to be continuing with our topic vectors. This is the fifth part of the section. And here we're going to be dealing with triple product of vectors. So here we have scalar triple product of three vectors. We have the coplanar vectors, and we also have the vector triple product of three vectors. There are different methods that we can use to get this that we have, but we are going to be focusing on the simplest one. Now, let's start with the triple product, the scalar triple product of three vectors. So now we'll be giving three vectors A, B, C, and they are in form of the directions I, J, and K. We have done that in our previous section. So let's say we have A as A1I, that is in the I direction, plus A2J plus A3K. That is this in the I direction, this is in the J direction, and this is in the K direction. So same thing for B. We also have B1I plus B2J plus B3K. Same thing for the vector C. We can have it in three dimensions: C1I plus C2J plus C3K. Now we have to find the scalar triple product of these three vectors. It's going to be scalar, let me say STP, that's scalar triple product, is going to be A dot B plus C. And what is that telling us? They're telling us that we are going to do, the cross product is always leading to determinant. So you can always find the determinant of this B and C, that is this and this. Then you now find the dot product of whatever you get here with this. And mind you, when you are dealing with dot product, you notice that the direction will no longer be there again. When you do cross, you still have a direction I, J, and K there. But when you now dot it with another vector, there will no more be I, J, and K there again. That's the function of dot. So now, that's the basic explanation for this. Let's take an example briefly. So we have A equals to 2I minus 3J plus 4K, and we have B as I minus 2J minus 3K, and we have C as 2I plus J plus 2K. Now, from the formula, we already know that our scalar triple product is going to be STP. It's going to be A into bracket B multiplied by C. So we already have our C. You can as well say you want to create a determinant altogether, putting A at the top and B and C on that is going to lead you to the correct answer. But for more clarity, we are going to be taking it one after the other. So let us take B plus C first. Let's do that first. So for B plus C, we have the determinant B plus C. So now here, what's our B? Let's first put our I, J, and K. Then our B is I is 1, then J is minus 2, then K is minus 3. Then here we have our I as 2, our J as 1, then our K as 2. Now let's simplify further. When we simplify further, we are going to be having here. Let me not omit this. Put our plus minus plus. That's the rule that we use in determinant. So now this, we take out this and this, then we focus on this. So we'll be having I into minus 2, 1, minus 3, 2, then minus J. This goes out, we have this and this. So we have 1, 2, and minus 3, 2. Then we have plus K. Here we have this goes out, we have this and this. That's 1, 2, and minus 2, 1. So basically, we can solve for that. So now for I, now what are we having? We multiply this by this, then minus the product of this and this. That's the rule for determinant. So minus 2 multiplied by 2, that's minus 4. Then minus, we have minus 3 multiplied by 1, that's minus 3. So this will change to plus automatically. So here we have minus J into bracket. This multiplied by this will give us 2. Then minus, we also have minus 6 here. So that this will change to plus 6. Because minus times minus is plus. So then plus k, open your bracket, then this multiplied by this is 1, then minus 2 times minus 2 times 2 will give us minus 4. This one turns towards plus. So you have plus 4 here also. So and here we'll be having minus 4 plus 3, that's minus 1. So we have minus I, then minus 2 times 6 is 2 plus 6 is 8, 8j plus 5k. That is our value for B cross C. Now we now dot it with this A. You know we are given A indication. So now you can now say A dot B cross C. We have gotten this here. So we now bring them together. What will we be having? Let's bring this here. We have 2I plus 3j plus 4k dot this here minus I minus 8j plus 5k. Now the dot is that you multiply the corresponding unit vector with each other. So by doing that, the unit vector will disappear. When you are dotting, you don't have unit vector again. So now 2 multiplied by minus 1, that will be minus 2. Then you have minus 3 multiplied by minus 8, that's plus 24. Then you have plus 4 multiplied by plus 5, that's plus 20. So if you are calculating that, we should have 42. That means this answer here is 42 for this question. So that is the basic knowledge for that. But in case you want to do it directly, you can create your matrix in all together in just one place by saying that, you know, this is A dot B then dot C. You can just create that matrix and say that this, you can create it to be 2 minus 3 then plus 4. Also you take your B2 and place it under as 1 minus 2 and minus 3, and here too you have 2 plus 1 and plus 2. You see that when you do this, you can do it in the comment section and reply. You can see that when you do this, you still have the same answer as you have here. So it is still the same. Now you notice that there is no more unit vector here. That's telling you that if you dot 2 vectors, you will not have any unit vectors again. So now let's move to coplanar vectors at this place. Coplanar vectors is just that when you have the scalar triple product of 3 vectors equals to 0, that's when you call that vector coplanar. If it is equals to 0, you have that vector as coplanar. So I'll just say that this is just meaning that if A dot B plus C is equals to 0, then you say it's what? It's a coplanar vector. So let us take an example on that. Let's say we have 3 vectors here, A, B, and C, and we have A as I plus 2j minus 3k. Then we have B as 2I minus j plus 2k. And we have C as 3I plus j minus k. Now you have to show if this is what coplanar. Show here, let's write it here. Show if the 3 vectors are coplanar. Now we have to do. So if you calculate this and it leads to 0, that means it is coplanar. If it doesn't lead to 0, that means it is not coplanar. So let us check this out. Now we can now use that second method that I spoke about. Let's combine all the vectors in a single determinant so that we still get the same answer. So see the same process. Let's say we have this now. Remember, this is what? A dot B multiplied by C. Still this. So now let's pick them out. Here we have 1. Here we have 2. Here we have J as minus 3. And here we have I as 1, J as minus 1, and K as 2. We have I as 3 here, J as 1, and K as minus 1. Now we can bring out the determinants here. We have 1, this goes out, we have this. So we're having minus 1, 1, 2, minus 1. So that's for that. Then remember that we have plus, minus, plus also. You shouldn't omit that. plus minus plus. So here we have minus 2. This goes out. We have 2, 3, 2 minus 1. Then plus, we have plus minus 3 here. So plus and minus will give us minus. So we have 3. This goes out. This goes out. We have this. We have 2, 3, and minus 1, 1. So now we can now solve out the determinant. What will be adding? We have 1 into bracket. This multiplied by this will give us 1. So 1 minus this multiplied by this, that's 2. Then minus 2 into bracket. This multiplied by this will give us minus 2. Then minus this multiplied by this will give us 6. So we have minus 3 into bracket. This multiplied by this will give us 2. Then minus this multiplied by this will give us minus 3. Then minus 3 times this will give us plus 3. So what do we do here? We can solve further. 1 minus 3 is minus 1, and minus 2 into minus 2 minus 6, that's minus 8, then minus 3 into bracket 2 plus 3, which is 5. This thing is so let's calculate this together. I'm going to be having minus 1 minus 2 times minus 8 will give us plus 16. Then minus 15 here. So you can see that it is leading to 0 because minus 1 minus 15 is minus 16. Then minus 16 plus 16, that will give us 0. So that means these vectors are what? Coplanar. This is a coplanar vector. Obviously these are, so there are 3 of them are coplanar. That's why it is leading us to 0. The product, the A dot B multiplied by C and B cross C will give us what? 0. That means it is coplanar. So now without wasting much of our time, let's go to the last part of this section. So we are dealing with the vector triple product of 3 vectors. Now in this case, we are having our formula as we say vector triple product is equals to A cross B cross C. Now in this case, we find the cross product of B and C. And when you get the cross product of that, you now cross it again with the A. So now let's take a simple example on that. You have A, B, C. Let's see what's going on here. If our A is 2I minus 3J plus K, then we have our B to be I plus 2J minus K, and we have our C to be 3I plus J plus 3K. Now, first thing to do is what? Look for the B cross C. There is a formula too that is also for this one, but you have to get the process. Let's start with the basic process. Now we cross these two together. So we say B cross C, because remember when you are crossing two vectors, so you include that I, J and K. But when you are doing the scalar two products, you don't need to include it when you are combining them. So now we say for this one we have I, J and K, and you have plus minus plus. Then for B here, for the I part we have 1, for the J part we have 2, for the K part we have minus 1, and for the C part we have 3, the I part here, the J part here we have 1, then the K part here we have 3. So what are we doing here now? We apply the determinant rule. So here we say I, we say I into brackets, and let's do the determinant rule. So this goes out, this goes out. We have this here. 2, 1, minus 1, 3, minus J. This goes out, this goes out. We have this and this. 1, 3, minus 1, 3, then plus K. This goes out, this goes out. We have this and this. We have 1, 3, 2, 1. So now we can simplify further. So in our I now we have 2 times 3, which is 6. Then minus, this will give us minus 1, is equal to plus 1. Then J into, here we have this multiplied by this, or this multiplied by this, we have 3, minus, this also gives us minus 3, so this one will change to plus 3. Then we have plus k. This multiplied by this will give us 1. Then minus, this multiplied by this will give us what? 6. So now we can say our I is what? We have 7i here. 7i, then minus 6j, then minus 5k here. Now we've gotten our b cross c. Now we are using this b cross c to cross our a again. That's another determinant in this case. So now say this now will be what? Remember, when you are crossing, you still have a unit vector there, so you don't need to omit that. You see, you need to include your unit vector. So we are still having that I, j, and k. That's when you are crossing. But if you are dotting two vectors, there will not be any unit vector there again. So now, here we have our 8 zeros. 2 minus 3, 1. That's from here. Then our b cross c here will be 7 minus 6 minus 5. So now what do we do from here? We follow our normal method. Let's manage here. We have I. Let's do the determinant from this. So we take this rules out. We have this. We have minus 3, minus 6, 1, minus 5. Then plus minus j. So this goes out. We have this and this. 2, 7, 1, minus 5. Then for the last one, plus k. We have this goes out. We have this and this. So 2, 7, minus 3, minus 6. So let's come in. From there we'll be having our I. This multiplied by this will give us 15. Minus cancel minus. We have 15 minus 6 multiplied by 1 is minus 6. So when it comes here, minus multiplied by 1, we change this one to plus. That is 15 plus 6. Then minus j into bracket. This multiplied by this is what? Minus 10. Then minus, this multiplied by this will give us 7. Okay, now plus k. Open bracket. This multiplied by this will give us what? That's minus 18. Minus 2 times 6 is 12. Minus 12 rather. Minus 12. Then minus, this multiplied by this minus 21. So this will turn to plus 21. So now you can now combine. 15 plus 6 here will give us 21. We have 21i minus, here we have minus 10 minus 7, that's minus 17. Then minus multiply the minus outside, that will be plus 17. Plus 17j. And the last one here, we have minus 12 plus 21. That should give us plus 9. Yes, plus 9. So we have plus 9. So this is our answer for the vector triple product of 3 vectors. This is the end of this video. We are still not done yet. We are still going to be doing the definition and integration of vectors. Do well to like, share, subscribe, and follow. Thank you very much.